Okay, so this morning, our speaker in the second installment of our spring 2021 Environmental Friday lecture series is Dr. Motria Caudill. I hope I pronounced that correct. She's actually been a very great supporter of our program here to try to incorporate environmental science issues into our chemistry high school course. So I thank her very much for that. In fact, she did a lecture for us last school year. And this school year, she's actually going to do 2 lectures. Today's, which is going to be on outdoor air pollution. And I think the next one later on is on climate change, I believe.
February 6th.
February 6th. Okay, there you go. So Dr. Motria is an environmental health scientist with the Agency for Toxic Substances and Disease Registry. It's part of the CDC, Centers for Disease Control. She's also an adjunct associate professor at the University of Illinois in Chicago School of Public Health. She's traveled around the world to places like India, Vietnam, Ukraine to do research projects and to train local specialists. She has a PhD and master's degrees in environmental and occupational health sciences, and they focus on toxicology, risk management, and air quality, which is why she is well qualified today to talk to us about outdoor air quality and your health. The floor is yours.
Wonderful. Thank you for having me back, Dr. Murray. So I will only see my slides, and please do, if you see something in the chat box, or I guess if you're in person, if someone raises their hand, I'm happy to answer a question as we go along.
Okay.
It's a really big topic, but I'm trying to focus on some of the more interesting parts. So yes, outdoor air quality and your health. Thank you for having me back. And I look forward to seeing you again in a couple weeks.
All right, sounds good.
We're going to talk about the basics of air pollution and who is at risk from these air contaminants. And then I'll give you some resources on accessing real-time air quality data and what you can do to protect your health and sensitive persons in your family and in your community. So yes, I'm an environmental health scientist. I've been in this field for 25-ish years, currently on faculty at UIC School of Public Health, also teaching a course at Andrews University. So I'm happy to be expanding my academic credentials. And I've also worked for the federal government for 20 years. My presentation today is not representing my current or previous employers, so this is my disclaimer. But a lot of my experience in air in particular comes from working for EPA for many years. So first part, talking about air pollution basics. Why is air pollution important? I'll tell you, when I first went to graduate school for environmental health, I was interested in drinking water. It's something so tangible, and we know about water pollution, and I hadn't even really thought about air pollution. You don't see it, you don't taste it, but once I started learning about it, I saw how very critical it is, and that's how I ended up on this career path. So you never know quite where you're going to end up. Here's some statistics from a national, or rather an international study. This is the Global Burden of Disease, Injuries, and Risk Factors Project. It's been going on for a number of years, and specialists worldwide have been trying to identify and rank and figure out solutions to the highest risks to premature death in the world. And you'll see that ranking right up there with a lot of the best known health issues and lifestyle issues is exposure to air pollution. Air pollution is the 4th leading risk factor for early death worldwide. It's estimated that 6.67 million people in the most recent year of this study, in 2019, died largely due to exposure to air contaminants. This total number does include indoor exposure, so that would be homes where they have wood burning stoves to cook and to heat. So that's a little larger than the number for outdoor air pollution, but outdoor pollution is indeed a large component. And it's right up there with high blood pressure, tobacco use, dietary risks, high LDL, high body mass index. So these are largely dietary and lifestyle factors, and air pollution is right up there with these causes of premature death. So how exactly does air pollution affect us? It contributes to several different categories of diseases. An extensive body of scientific evidence has shown that breathing contaminated air contributes to increased risk of illness and death from these illnesses and diseases listed here. So cardio obstructive pulmonary disease, diabetes, ischemic heart disease, lower respiratory infections, lung cancer, neonatal deaths. This is a major new area of research, and stroke. So these are a lot of largely heart and lung related conditions where the symptoms and in some cases premature death have been found to be caused by pollution exposures. And I'm interested in global health. I like to put things in the context of what's going on in the US compared to other developed countries, wealthy countries, the US compared to countries that are currently developing. And so I found it interesting that air pollution is actually, it's related to the income level of a country. And this graphic here shows you how death rates from air pollution is highest in the middle income countries. So this would include Egypt and many countries across Asia and Central Europe. This is the former Soviet Union, and then Asian countries such as India, China, Pakistan, and Bangladesh. So these are countries where the effect is this, that the death rates related to air pollution exposure tend to rise as countries shift from low income to middle income because they're industrializing. So the countries that don't have industry and cars and a lot of power plant pollution, they may have the indoor pollution issue, but they don't have major sources of concentrated outdoor air contaminants. But as countries grow and industrialize and the cities get bigger, that's when the exposure to air pollution and related deaths are at their peak. So this would be in the middle of this chart. And then as the countries become more wealthy, more industrialized, and as the democratic process leads to people demanding better health and better protections, then they tend to implement environmental controls, and the death rates fall as the higher incomes, both because of air pollution and just overall health improves. So how do we talk about air pollution? I have some pet peeves when I hear about air contaminants referred to as, quote, a toxic soup. I don't really find that helpful or productive. And so I'll try to get you a little more informed about some specific air pollutants of issue. It's true that there are hundreds of and even thousands of air contaminants that have a known health effect and that we could be potentially exposed to on a routine basis. But there's really a short list of air contaminants. In the US, there's 6 pollutants that are common enough and widespread enough and understood well enough that we've able to go ahead and establish air quality standards. So we know their health effects well enough. We know what concentration corresponds to what health effect. And so we've established safe levels. So in the US, you may be surprised to hear this, but yeah, we only have air quality standards for 6 pollutants. And then of these, 4 of them are very well regulated in the majority of communities. And there's really 2 pollutants that contribute the most widely to health impacts in the most communities. And these are particulate matter, PM, also called soot in news articles you might read, sometimes called particle pollution. So if I say PM, it's particulate matter. And then ground level ozone. or smog. And those two, they can go together, and those phrases are sometimes interchangeable. But that's ground level ozone, not to be confused with stratospheric ozone. You may have heard that there's an ozone layer, and it's important to protect us from excessive radiation from the atmosphere. So there's the way they say it is, it's good up high, bad nearby. So it's the same chemical. It's good to have it in the ozone layer, but we don't want it down at ground level. So ground level ozone is regulated in many countries. So I'll tell you some more about these two pollutants. Particulate matter and your health. PM is linked to premature death in people with heart or lung disease. It can affect heart and lung function, and it can aggravate existing conditions such as asthma. People who are most sensitive to the effects of PM are those who have a pre-existing heart or lung condition, children, and older adults. And this graphic shows you the different sizes of particulate matter. The large particles greater than 20 or 30 microns in diameter don't really enter the respiratory system. They get caught in the nasal passages. And if you're near a campfire or some kind of an exposure of large ash and particles, you may find it in your nose sometime later. And those are the particles that get caught by your protective system and don't get into your lungs. But it's particles less than 10 microns in diameter, especially those that are a fraction, that are 2 or 1 or even less than 1 micron in diameter. Those are the ones that travel all the way into the lungs, where they can have a severe effect. And I know nobody has visuals of what microns look like off the top of their head. So here is a chart to show you that the common width of a human hair is 50 to 70 microns. So those particles that penetrate into the lungs, PM10, are a fraction of the width of a human hair. And then PM2.5, those that travel all the way into the deepest parts of the lung, those are much smaller than the width of a human hair. And a piece of beach sand is more on the level of 90 microns in diameter. So where did these particles come from? The larger particles, meaning those that are PM10 or greater, those are actually directly emitted from or released from industrial smokestacks, from car exhaust, dust from construction sites, dust from farming activities. So a lot of, that's a primary pollutant, meaning that it comes directly from the source in the form that it's released from the source. The smaller particles, PM2.5 and smaller, those are actually formed in the atmosphere as a result of chemical reactions. So you have so-called precursor gases, including sulfur dioxide from coal-fired power plants, nitrogen dioxide from car emissions. Hard to wrap your head around this, but it's there's a lot of, maybe next time I'll include some more chemistry. I left it out this time. But a lot of these precursor gases react in the atmosphere to form tiny, tiny little particles, also called aerosols. And so most of these smaller particles are actually formed in the atmosphere. Okay, and I'll tell you one more thing about when it is that we have PM2.5 at high levels. We have, where we are in the Midwest, we've got a very distinct winter, summer, 4 seasons. And where we are, the PM2.5 levels tend to be the highest when there's an atmospheric inversion, which can happen, I think it's been happening the last few days. We have, in Chicago at least. So it's very common in the Midwest in the winter season. So what an inversion is in contrast to, on this chart that you're looking at here, on the left side, without an inversion, on a nice warm day or a windy fall or spring day, warm air at ground level rises, and as it rises, it mixes. And so that's just, it's atmospheric mixing. So whatever those little dots all over the graphic, that's pollution being emitted by your cars, by your power plants. So we have pollution emitted at ground level, and it disperses. it rises and the winds carry it. So it disperses and people are exposed to less pollution as it disperses. But what happens in certain wintertime weather patterns is you have a layer of warm air which sits up on top of a layer of cold air, and this is about 1 to 3 kilometers above ground level. And that warm air, it's a stable layer and it just sits there, and it's called an inversion, and it traps pollutants at ground level. So if we have a 2, 3, 4 day period in the wintertime where the atmosphere is not moving and it's not mixing, then those contaminants at ground level can add up, and it's PM 2.5, plus there's other pollutants. There's been historic events where you've also had some sulfur dioxide or other contaminants that can actually lead to, if it's high enough concentrations, it can cause major symptoms for a lot of people, and deaths have been reported. But in our day-to-day, we generally, this is something that you may, if you start tracking air quality in your area, you may find that there are some inversions, and maybe even in the next few days. Okay, so moving on. Ozone, switching gears, ozone is a summertime pollutant. And the graphic here shows you that the way we get ground level ozone is, again, we have precursor chemicals. Ozone is entirely formed in the atmosphere. There's no smokestack or industry that's pumping out ozone. What happens is the nitrogen oxides from vehicles and the volatile organic compounds, VOCs, from paints and print shops and from refineries and industries that emit VOCs, those two categories of precursors react in the presence of sunlight and on days with warm temperatures. And so they will peak in the summertime. The reason ozone is harmful is it's very reactive. When it touches the surface, it immediately transforms to oxygen. But in its reactivity, it can harm biological human tissues. So it affects the respiratory system. Ozone can trigger chest pain, coughing, throat irritation, and airway inflammation. It can worsen bronchitis, emphysema, and asthma. Those who are most sensitive are people with asthma, children, older adults, and people who are active outdoors because they're exposed to it far more than people indoors, especially outdoor workers. Ozone is formed entirely in the atmosphere when these precursor gases react in the presence of ultraviolet radiation. So as I mentioned, PM can build up over the course of several days. Ozone has a day-to-day pattern. It peaks on hot days and in the afternoons, especially. That's when it forms. The first graphic here shows you, this is from New York City. This is very typical of data you might see in Detroit, Chicago, any number of large cities. This is the highest ozone versus the highest temperature matched on specific days. And you'll see the relationship that the higher the temperature, and this is Celsius, the higher the temperature on the x-axis, the higher the maximum daily ozone is reported on those days. And to see the time pattern, the second chart I've shared with you here is ozone versus time of day. And it's the same worldwide. A lot of, many countries face the ozone challenges that we do. These are, the red and blue lines are cities in Japan, and then the 3 other lines are cities in Mexico. And they all have the same pattern that we have in the United States, where on these hot summer days, ozone levels can be lowest in the early morning, 6 to 9 a.m. There's actually reasons why it's depressed. That's the morning rush hour, and it goes down to its lowest point. And then throughout the day, as temperatures rise, and as those chemical reactions are ongoing, the levels increase and increase. And then somewhere around 3 p.m., 4 p.m., that's when the highest levels are observed. And then the ozone actually starts breaking down and dissipating, and it goes back down to a lower level overnight. So we may have several days in a row of similar conditions and we'll have high ozone, but it actually still follows that day-to-day pattern. So that is how the pollutants are formed and who is at risk. And then to say a little more about risk factors, in the United States, the Environmental Protection Agency has found that race is the strongest predictor of PM 2.5 exposures in our communities. They found that non-white people face higher exposures to PM than white people in all but 4 states. So the exceptions, and I thought about why these might be exceptions. The exceptions, one is North Dakota, where I think they just don't have big cities. And then 3 areas around the Washington, D.C. area. And in those cases, I think everything is just so clustered and jammed together, the populations, the cars, the industries, that there wasn't, that teasing out the different communities didn't go so well. But in our area, our Midwestern states exemplify this issue pretty well. And Indiana in particular, the bottom line is that the communities that live, it is people of color who live closest to these industrial and urbanized areas where they're facing exposures to the mobile sources, to the industrial emissions. So we know that particulate matter is very linked to race in the United States. Ozone less so, because ozone is more of a large scale pollutant. It's formed in the atmosphere and it travels. And so it affects communities well beyond those specific neighborhoods. So people of color living in Indiana and Alabama are exposed to roughly twice as much particulate matter as white people. And then another aspect is age, and this is returning again to the global study I referenced at the beginning, global air pollution deaths versus age. And you'll see on the chart going from infancy up to ages 80, 90, 95 plus. And what they included on this chart is exposure to PM 2.5, ozone, as well as the household air pollution that I mentioned. But all of those categories, the deaths attributable to these 2 main contaminants and indoor pollutants they do affect both infants and neonatals, and then people above a certain age. Okay, and then one last thing about who is at risk. The CDC has confirmed that communities of color have experienced some of the worst effects of COVID-19. So the most likely to be exposed and to catch the disease, and then the most likely to have negative health outcomes. Many studies have also documented that communities with more Blacks or Hispanics have higher air pollution levels. And this is all coming together, and there's research ongoing finding that high exposures to air pollution can increase the risk of contracting COVID and having worse outcomes. So there are people across the country who are looking at how all of these factors interplay, and I think it'll be something interesting for us to track into the future. So people who are predisposed to negative effects of air pollution and infectious disease may be getting everything all synergistically affecting them at the same time, causing disproportionate effects. Okay, so now we're moving on to, now that I think we have a good overview, did Dr. Murray, did we have any questions, or should we power on?
In the chat yet? Any questions, you guys, yet? Not any from the class yet.
Okay, no problem. All right, so now we'll talk about how do we get this information about air quality, and what do we do to protect ourselves and those close to us. So accessing real-time data and taking action. Here's a photo of a few different air monitors on a rooftop platform. This was the office that I used to work at EPA. We were focused on air monitoring and data analysis. So this is something that I worked on for a long time. These are different PM monitors. And the way these monitors are placed is they're intended to be in an area that represents a large zone of space. So you'll see the monitors. I mean, there's a couple of trees there, but the monitors are not blocked in by tall buildings or anything. There's a free airflow And so the data collected at a site like this, up on a rooftop, very often it's on the rooftop of schools, universities, libraries, police stations, public buildings that allow access to the rooftop. And so these data are collected by state agencies. The long-term data is used to decide whether they're attaining the air quality standards. So we've defined safe levels of PM and ozone and other contaminants. And we have a nationwide network of regulatory air monitoring stations to collect data and figure out which areas are meeting those standards and which ones are not. So that's the regulatory purpose. But then in real time, a lot of these monitors are able to report PM and ozone to public websites, accessible websites, where it's important for public information and for people to take action to protect their health. And in addition to this real-time data, there's also a whole other process called air quality dispersion modeling, computer modeling, which is used to predict air quality over the next 1 or 2 days. And the reason that we're able to do this is because the production of ozone, it's the precursor chemicals, your nitrous oxides emissions, your VOC emissions. We have a good enough estimate of how much and where these precursor chemicals are emitted that computer modeling can be done to actually map out, given a certain predicted temperature, given a certain predicted wind speed. They pull it all together and they can predict if tomorrow or the next day is going to be a high pollution day. So all of this information is put together, and the other half of it, very important, is interpreting the results. So the real-time information that I'll show you in a second how to access this, it's all put in terms of the air quality index, the AQI, which tells us how clean or polluted our air is and what associated health effects could be a concern. And we think of the AQI as a yardstick that runs from 0 to 500. The higher the number, the higher the AQI, the greater the level of air pollution and the greater the health concern. An AQI of 100 is equal to the regulatory standard. So 100 is the PM 2.5 standard. It's also the ozone standard. In reality, these pollutants have their own air quality standards, but what the AQI does is it normalizes and puts them on the same scale. So you don't have to worry about the actual standard and the actual concentrations. And then you'll see that there's, these are screenshots that I took from, this is from August. It was a day where in Houston, the AQI, and it says right there under that orange block, it says ozone. So this was a day over the summer where they had those conditions of hot temperatures and still air that caused high ozone levels in Houston. We had it in the Midwest too, but this is a particular one that I caught for Texas. And then the orange color signifies unhealthy for sensitive groups. And then above orange, you'll see it gets to red, purple, and maroon. So the standard is 100. If it's a little bit above the standard, then it's unhealthy for some people. Well, what if it's even higher? Here's our color scheme, understanding the AQI. So whether it's particulate matter in the winter or ozone in the summer, the color scheme is the same. If you're less than half of the standard, so less than 50, that's categorized as green or good. Air quality is considered safe and it's not a health risk for hardly anyone. 50 to 100 is moderate. This is very common actually. Air quality is acceptable, but there are some people who are especially sensitive to air pollution effects, folks with pre-existing conditions, so they are potentially affected. And then once you get to the orange and the red and the darker colors, it's more likely to be a health concern for a greater fraction of the population. So in addition to letting folks know that there's a potential health effect, the website that I'll show you in a second also recommends what you need to do to protect yourself. And the bottom line basically is to remove yourself from those exposures. So if it's a day where it's predicted or observed to be unhealthy or even very unhealthy, then you don't want to be out walking around and exerting yourself in that kind of a situation. So that's the overview of AQI. Now the website that, I'll give you the link in a second. This is pulled together on the airnow.gov website. Air quality can be predicted by modeling 1 to 2 days ahead of time, and then also it could be displayed in real time. So if you pull up this website in a second here, it defaults to showing you your location. It wants to know where you are and tell you your most immediate information, but there's also links you can see within national maps to see what's going on in other parts of the country. So these ones I downloaded in August, and that was a time when this is actually a pretty common summertime situation. So on this day, August 19th, the current air quality on the left and the air quality forecast, the modeling predictions on the right. So this was a day when a number of communities were expected to have high ozone. And as much as we sometimes have issues in the Midwest, Southern California is for sure the worst affected by air contaminants, partly because of the density of population, all the cars, the industry they have, and also they have, it's the geography. You have winds coming in from the ocean, and then there's the river valley, and the dispersion of pollutants is stopped by the mountains. So everything gets trapped there. So they have unique challenges in California. Earlier in the summer, in the spring and earlier in the summer of this past year, there were a lot of wildfires, not just California, but all over Oregon and Washington. So you may have seen some news articles where they were saying that they're comparing the air contamination level around Seattle or around Portland, and they would say that it's the worst in the whole world. And it was for a number of days, because this kind of monitoring and the AQI is adopted by many countries around the world. And there was a running period of time when the particulate matter, the PM from wildfires, was so extremely high out in the Pacific Northwest this year. So that's another thing. Here, I'm showing you here a screenshot of that AirNow website. So it did, this was initially developed largely to help people get information about PM and ozone. But if you look at the tabs across the top, it says AirNow, AQI and Health, Fires. There's a specific tab for, there's another map included that shows where the current fires are. And then there's recommendations on safety from air pollution from fires specifically. Okay, moving on. So in addition to periodically checking that website, which I'm sure you would forget to do, there's another tool here. It's called Enviroflash. So Dr. Murray, if you could, I don't know if your students are allowed to have phones or iPads in the classroom, but they could feel free to pull up the website.
Okay.
So there's the, or maybe you could show it if you have a split screen or anything. But
they have cell phones.
Okay, so if you look at airnow.gov, you'll see, I checked it earlier. I don't think there's much of anything going on today. This is a pretty quiet time of year.
Okay.
And then over on the right side under resources, I've circled for you here, Enviroflash emails. You can sign up for notifications to be received. It can be texted to you or it could be emailed to you. And I signed up to get my Enviroflash emails for Chicago many, many years ago. And so if it's currently a high pollution level or if it's predicted for the next day, I'll get a notification of it. So that's the main thing I wanted to show you on the website. And then, of course, there's an app. There's the AirNow app. And this was developed by EPA in partnership with state agencies. State regulatory agencies actually do the air monitoring and they do the modeling to predict high pollution days. So this is a very nice partnership between different entities. If you put this app on your phone, it'll sense your location and it'll tell you. This screenshot here, this was for Raleigh, North Carolina, and the day that I grabbed this, it was forecast to be moderate on the day of, and then the next couple of days were expected to be good. So if we have a minute, I think once I wrap up here, maybe I'll pull it up myself and show you a couple things. But just to recap, so who is at risk from air pollution? If we're focused on the most common pollutants where we are, ozone and PM, it's children and older adults that are most susceptible, people with pre-existing heart and lung conditions, people of color and in low-income communities, and those who work outdoors for long periods of time. So what can we do to protect health? You can put the AirNow app on your phone. You can sign up for Enviroflash notifications, and then tell a friend, tell someone who is at risk, a friend or family member, about these tools. Get them signed up, show them how to do it, how to get those notifications. If you have someone who's really got asthma issues, people who have asthma, they tend to, they need to know their different triggers. And so air pollution exposures in the summertime is pretty commonly known as a trigger of asthma. So that's something they could add to their toolkit about things to do to protect themselves. And then if it happens to be a hot day and there's high ozone levels, check in on people that you know are susceptible to its health effects. And then if you yourself are at risk to any of these conditions, then track the air pollution levels. And if it is a high pollution day, adjust your activities. Make sure that you're not outside for long periods of time, especially not exerting yourself. And we like to make sure that this is not entirely put in negative terms. So we don't just say, oh, the air is bad, stay away from the bad. What we want to do is put a positive spin on it too. So if you know that you're trying to watch your diet, you're trying to exercise, if you want to get out and go for a long walk or a jog, say 2 times this week, look at the predictions and see, today is a good day for me to get out and exercise. Tomorrow, maybe not. So you definitely do need to get out and be active and tell your family and friends the same. But if they are potentially at risk from air pollution effects, then plan around those days where the air pollution might be a little more severe. So a couple more things you may have seen. They used to call them ozone action days, but then they decided they call them just in general air quality action days. Here's a couple examples. This first chart, and the focus of these charts is not so much if you're at risk from a health point of view, but this is what we can all do to limit air pollution on those days. So whether I'm worried about my asthma or not, I want to do what I can to limit my release of those precursor chemicals. So the graphic on the left, this is from the state of Pennsylvania. Air Quality Action Day, they're predicting that the next day was going to be a high ozone day. And so how can you reduce air pollution? And those check marks there are listing off for you. Conserve electricity by setting air conditioning to a higher temperature. And that's because power plants emit a lot of those precursor chemicals. So conserve electricity, don't drive around a lot, combine your errands, limit engine idling, don't have your car sitting and running for a long period of time, refuel cars and trucks after dusk. That's because when you're at the gas station putting fuel into your vehicle, there's a lot of VOCs released from that process. So the recommendation is if it's expected to be a high ozone day, then there's some things that you might want to put off to another day so you're not contributing to air pollution. So that was Pennsylvania. And then the second one, this is one of EPA's, this is Chicago metropolitan area. So they're recommending ground level ozone is expected to be elevated today and through the holiday weekend. Sensitive individuals should take precautions. So they took more of a health angle with this particular graphic. And this is from the CDC website. They have a few different graphics. And if you end up working in a community group or in a health agency of some kind, there's flyers, there's posters you could put up. So let people know. I am air aware. I love being outside when the air is healthy, but I use AirNow for text alerts about my local air quality. So this is a personal interest of mine, is trying to let people know that air pollution can affect your health, but there's resources readily available to help you find out more about it, to how to protect yourself and those around you. So thank you for your attention. I'm going to pop over and pull up the website if I can. I think we have a couple more minutes. So if you have any follow-up questions, you can email me at mcaudill@uic.edu. I also tweet about global environmental health issues at Motinka, Motinka, if you want to follow me on Twitter. So thank you for your attention, and hopefully we have a little time for questions.
Okay, do you guys have any questions? No questions? I have people on the line though, chat. John, are you still there? John, are you still there?
Yeah, I'm still here.
Okay, you want to go ahead and ask your question?
Oh, yeah, well, it is kind of current event. I saw that Southern California had lowered a temporary lowering of their air quality standards to allow for more cremations to take place, given that their high death count. Has it been your experience to see air quality taking a back seat to other health concerns in some of the areas you've worked?
Yeah, I think what you're referring to in California, that's an extreme and unique situation because they have, I mean, when it comes to categorizing non-attainment areas and the steps that need to be taken to bring the area back into attainment, California is always in it. They're always a whole other category because of their population density and all those other factors. Yeah, I found it interesting when the lockdown started in March and people weren't driving as much, that for the short term at least, this was observed with satellite measurements over China and other parts of the world, that air quality actually improved for a period of time. Yeah. But just the broader question of whether air quality or environment in general takes a backseat to other issues, I think that's always the case. When earlier in my presentation, I had that curve of how air pollution is and contribution to health is the most severe in the developing countries, in the middle income countries, because they are trying to get their people to a middle class lifestyle. So they're building factories, people are buying cars, and they're building power plants, and they're doing everything they can to get their economies going. And then once they reach a certain level, then the next phase is when they realize, oh, okay, now we need to protect people's health. And it's unfortunate that environment is considered to be separate from health, because especially with air contaminants, we see how it is related. And air pollution is not something that's just bothering the trees, it's affecting people's health, it's causing the death of people. So it's unfortunate to have environment and health separated, but yeah, it is paid the most attention to in the highest income, highest lifestyle level countries, where people are able to pay attention to that and to demand it of their government. So I hope that kind of addressed it.
Based on what you know here about our area, do you think air pollution is a big issue in like Berrien County, Southwest Michigan? And
I'm glad you mentioned that. Yeah, I didn't include it today, but we designate areas as being attaining or non-attaining the standard. And so the particulate, the PM 2.5 standard, the whole Midwest is meeting the standard, which is not to say that we don't have some high days, especially in the winter time. So hopefully folks will keep tabs on that. But ozone is more of an issue in the Midwest. Multiple counties of the Chicago metropolitan area are currently in non-attainment of the ozone standard. And because those precursor chemicals and the formation in the atmosphere happens over hundreds of miles, Berrien County is actually in non-attainment of the ozone standard. And that's because the emissions, the precursors and the ozone formation that happens in Northwest Indiana, largely, and in Chicago, these pollutants travel along the east and the west coast of Lake Michigan. So you have, it's not just Berrien County. I think there's another county or two even north of you that are violating the ozone standard And it's not that you have a whole lot of industry or a whole lot of cars in Benton Harbor, you know, not compared to the other cities. It's largely traveling from outside of the county. So I think if I were talking to a group of people in Northwest Indiana, I might want to focus more on regulating industry, driving less, and bringing down those precursors. But where you folks are, a lot of it's beyond your control. It's wafting up along the lakefront, and hopefully you can work. Michigan Eagle, the regulatory agency, works in partnership with Indiana, with Illinois, and so they do have Great Lakes-wide plans. Right. But ultimately, I think the focus in your community is to know when it is that it's happening and what you can do to protect yourselves, right. And definitely advocate for improvements in air quality. But unfortunately, it's largely out of your control. Right. The ozone is. PM's another issue. We could talk more about PM another time.
Okay. So our students would need to go. It's pretty much 8:45. But I have a couple more questions I'd like to ask you, and we'll put the video up online. So today you focus mostly on like the sort of, I would say, except for ozone, like man-made pollutants, but and there are also a lot of natural sources of pollutants like VOCs come to mind, the Sahara dust comes to mind, other things like that, that may be beyond our control as well?
Yeah, absolutely. But it does come together because there are, there's a category of VOCs that are emitted from trees, right, that contribute to, they are actually ozone precursors. So there's terpenes and pimines.
Yep.
Yeah.
Yep. Mm-hmm.
Yeah, and people laughed and laughed when President Reagan said that trees are causing air pollution. And it's true, they do. They do contribute. So the thing is that trees have a lot of benefits, and we need to protect our forests and expand our forests. That's not to say that we need to get rid of the trees. We need to focus elsewhere to reduce the other precursors. But yeah, you're right. That is a source. And you know, I haven't heard about the Saharan dust lately. Was that this past summer? Was that an issue? Because it catches people's imagination. Those satellite photos and the videos, when they start showing those on the news, we start getting calls. Yeah, EPA and CDC, we start getting calls from people asking, should we be worried about this? And when those dust clouds are at their worst, they do travel across the Atlantic, and they impact the Gulf states the most. So there are days, and I tracked it at the time. So Houston, New Orleans, so some of these Gulf Coast communities, their AQI was definitely affected by the Saharan dust. But once it hits the Gulf Coast and then the air currents carry it north toward the Midwest, by the time it gets to where we are, it gets diluted, and it's not. I mean, there's still little bits of it that came up here, but not to the point that it would actually be affecting the AQI.
Right. And so on the plus side, again, with the trees, I know that pine trees in particular have been studied and been noted as great for carbon dioxide sequestration.
Oh, yeah.
Yeah, so they do emit, you know, trees do emit pollutants, at least precursors, but they also contribute in multiple ways as well.
Yeah, I'd say on balance, tree's good.
Yes, exactly. Exactly.
I'm pro tree.
Exactly. Okay, so one last question from me at least is, acid rain is no longer a problem in the US, correct? It's pretty much been a solved problem.
I put it largely, yeah.
Largely, okay.
Yeah.
Okay, but maybe places like China that has a lot of pollutants, smog and stuff into the air, they may still have
Yeah.
issues.
Yeah, if when I talk in more detail about air pollution, there's sulfur dioxide, SO2. We have, that's one of those 6 contaminants that we have an air quality standard. So we have very few areas that are exceeding the SO2 standard. And so in the Midwest and in the Northeast, it is more a factor of the SO2 transforming to acid and having the acid rain effect. But that's but they've been controlled and reduced so much that there's improvement. We have there's another network of they're called Deposition Monitors. So they measure contaminants as there's dry deposition, so it's particles and materials depositing from the atmosphere, and then there's wet deposition, rain. And so they've I've seen maps and trends over time where they've found that the acid deposition and the acidification of water bodies has improved. And it's because the SO2 has been controlled over the years.
Yeah, I think it's,
but you're right that it is an issue in some of these developing countries.
Yeah, I think it's a good example of how, because we always sort of focus on how humans are negatively impacting the environment. The fact that we, had a concerted effort to reduce acid rain, and it's, at least in some places, been solved, quote unquote, and improved, I think is a very good example. Even like the Chernobyl disaster, life is returning to Chernobyl,
Yeah. I like to talk about success stories. Another one is the hole in the ozone layer. So it was a few decades ago that we realized the ozone was being eaten away by chlorofluorocarbons, I think.
Exactly.
So we banned them. We banned them, and that's one of those global issues. So it couldn't be just the U.S. It was an agreement between all of the countries that are emitters of those compounds. And so it was at the Montreal Protocol. So everyone agreed to ban or phase out. And the ozone hole is shrinking. If you go to I think it's the NOAA website, and I've taken from there. So they show that it's kind of closing in, not entirely, but a lot of the harm that we cause can be reversed once we figure out what we've done.
Right. So I think those good news stories, will help people to realize that, yes, we could have a positive impact by changing our lifestyle or changing the way we do economics and industry and stuff.
Yeah, I think success stories are important, giving people a tangible idea of what they can do. One of the reasons I don't like that toxic soup phrasing is it just seems so unmanageable. So I think if we break it down and identify what are the priorities and what are the steps we can take, and just give people something hopeful to take away, then that's a lot more helpful than just throwing up your hands and saying it's impossible.
Exactly. All right. Well, thanks again. And we'll be seeing you February 5th.
Yeah. Thanks for having me back.
Yes, we'll have you back twice this year. In between your lectures, we have colleagues, I don't know if you know them, at the EPA, I believe, that will talk about indoor air pollution.
Yeah, they're from a different office that I was in. I didn't recognize the names.
Okay.
But,
all right.
But yeah, indoor air is a good program, so I'm glad you got those guys.
All right. Thank you very much.
Okay. Thanks for your attention.
Okay.
Bye, everyone.
All right. Bye-bye.